21, it says, which function forms a geometric sequence when x is equal to 1, 2, 3, and so on and so on. So a geometric sequence is when you have a common ratio, when you're multiplying the same, when you're multiplying a term by the same number to get that next term of the sequence. So remember, this is just in function notation. So if I look at question A here, when it says f of x, remember that's really just replacing the y. They could put a y there as well. So an f of x is equal to x plus 2, and they're telling us to use x is equal to 1, 2, or 3. So what I'm going to do is I'm going to plug in 1. So f of 1 is equal to, I'll plug in 1, and I get 3. So then when I plug in f of 2 for x, I get 2 plus 2, which is equal to 4. And then when I plug in 3 for x, I get 3 plus 2, which is 5. So the first three terms of the sequence are 3, 4, and 5. So if those are my first three terms of the sequence, and then this would continue, the question is it geometric? Geometric means I would be multiplying by the same number. So I would multiply 3 by the same number to get 4, 4 by that same number to get 5. Now, sometimes it's easy to see if there's a common ratio, and sometimes there's not. So what you can do is if you're unsure, this is where we would take, a term and divide it by the term before it. So like if I label this y sub 1, y sub 2, and y sub 3, and where I can take y sub 3, divide it by the term before it, and see what I get. That would be my ratio. So if I take 5 divided by 4, I get 1 1/4. So now I'm going to take my second term and divide it by the term before it. So if I take 4 divided by 3, I get 1.3 repeating. So as you can see, this is not a common ratio. I multiply 3 by 1.3 repeating to get 4. I multiply 4 by 1 1/4 to get 5. So since these are different, right, I'm not multiplying by the same number to get the next term in the sequence, it is not geometric. So I know that A is not a geometric sequence. So next we'll look at B and see if this is geometric. So for B, I have f of x is equal to x squared. And I'm going to plug in 1 for x first, and I get 1 squared, which is equal to 1. And then I plug in 2 for x, so f of 2, I get 2 to the second power, and I get 4. And then when I plug in 3 to the second power, I get 9. So the first three terms of my sequence are 1, 4, 9, and again that would continue. So if I want to find out if it's geometric, again, this is like my first term, my second term, and my third term, I take a term and I divide it by the term before it. So if I take term number 2, 4, and divide it by the term before it, I get 4. So that means that I take the first term, multiply it by 4 to get the second term. So then if I want to check, I take, for my next ratio, I would take term number 3, which is 9, and divide it by the term before it. So if I take 9 divided by 4, I get 2 1/4, which means that I would take 4, multiply it by 2 1/4, and I would get 9. So again, not a common ratio, right? I'm not multiplying by 4 and then multiplying by 4 again and then multiplying by 4 again. That would be geometric, right? When you're multiplying by the same ratio to get that next term in the sequence. So I know that letter B is also not geometric. So now I'll look at letter C. F of x is equal to x squared plus 2. So I'll plug in 1. So I get 1 squared plus 2, which would be 1 plus 2, which is 3. So 3 is my first term of the sequence. Then I'll plug in 2. 2 squared plus 2 is equal to 4 plus 2. So 6 is the second term of my sequence. And then if I plug in 3, 3 squared plus 2, 3 squared is 9 plus 2, and I get 11. So the first three terms of the sequence are 3, 6, 11, and then again it would continue. Now, sometimes you don't need to, take a number and divide it by, or take a term and divide it by the term before it. Sometimes you can tell, so if I go from 3 to 6, I know that to get from 3 to 6, I would multiply that by 2, right? So then to get from 6 to 11, would I also multiply that by 2? Well, no, because that would have to be a 12, right? So this is not the ratio to go that I'd multiply a 6 by to get the 11. So this way I can already tell that it's not going to be geometric because I'm not multiplying by the same ratio. So let's just see what the ratio would have been. If I take term number 3 and divide it by term number 2, so if I take 11 divided by 6, I get 1.83 repeating. So that's actually what I would multiply 6 by to get 11. So I can see here that C is not geometric, and then we'll go on and we'll check letter D. So let's check D. So I'm thinking geometric, or D is a geometric sequence unless we made a mistake on A, B, or C. So that's why you should always check it. Don't think just because, oh, the first 3 were not, it has to be D. Don't automatically just put D. You should check them all because maybe you made a mistake and then maybe you should go back and check A, B, or C again. So first I'll plug in 1, so I get 2 to the first power, which is 2. And then I'll find f of 2, so I'll take 2 to the second power, which is 4. And then I'll take f of 3, and I'll take 2 to the third power, which remember is 2 times 2 times 2, right? You're multiplying that base, you're multiplying this by itself 3 times. So that would be equal to 8. So my first 3 terms of the sequence are 2, 4, and 8. And then that would continue. And again, on this one, maybe you can just see what your ratio would be. In order to go from a 2 to a 4, I would have to multiply that by 2. In order to go from a 4 to an 8, I'd have to multiply that by 2. So I see that I have a common ratio. And if I wanted to continue, I would multiply by 2 again to get the third term, or the fourth term, multiply by 2 again, and keep going. So even if they asked you, what's the 8th term of the sequence, or the 12th term of the sequence, you would just keep multiplying by 2 until you get that term. So I checked my answer, and it works. So our answer is D. F of x is equal to 2 to the x power. That's our geometric sequence.